Welcome to the class, dear students. In today's lecture, I am going to do homogeneous differential equations. In the last lecture, I have completed the variable separable method to solve a differential equation. There are few methods. Number one, the first method was variable separable, which we did in the last class. Now, we are going to do with the homogeneous differential equations of first order and first degree. So to solve this type of equations, first we will understand what is meant by the homogeneous function, and then we proceed further for a homogeneous differential equation. Suppose if you have a function like f of x comma y is there. If this function is called as the homogeneous, this is called as a homogeneous function, is called as a homogeneous function of degree n, if it satisfies this condition that f of kx comma ky is k power n times of f of x comma y. Then we say that where k is a constant, okay. So then we say that the function is a homogeneous function of degree n. Let us see some examples. Let us say the function f of x comma y is given by some x square plus y square, let us say. Now what we have to do, in the place of x, let us replace kx. In the place of y, replace ky. Then on the right hand side also the same way, x is replaced by kx, y is replaced by ky. So kx plus whole square plus ky the whole square. So we can write it as k square x square plus k square y square. Now we can take common k square, right? So k square times of x square plus y square. So how we are able to write this as k square times of your x square plus y square is nothing but the original function f of x comma y. This function f of x comma y, x square plus y square, can be replaced here, which is nothing but f of x comma y. Therefore, this x square plus y square is what? Is the homogeneous function. Is the homogeneous function of degree 2. Homogeneous function of degree 2. This is called as the homogeneous function of degree 2. Let us have one more example. Let us check this. F of x comma y is suppose given as x square plus xy square is there. Now let us check whether it is homogeneous or not, and then find out what is the degree. So again replace x by kx, so it is kx the whole square, and replace again x by kx, that means ky the whole square. So that gives you k square times of x square plus kx times of k square y square. So now here what is common? Here it is k square and here it is k into k square. So you cannot write this as k power some power times of f of x comma y. So what you can say, this function x square plus xy square is not homogeneous. So I hope you could understand now with one example of homogeneous and the other example of non-homogeneous. Now here you can observe in a quick observation what it is if the powers of the terms are the same, suppose, then they are homogeneous. Now if you take this example, the power is here 2, whereas here the power is, for x the power is 1, y the power is 2. So the degree is here 3, the degree of this term is 2, both of them are not equal. So whenever the powers are not equal or not the same, suppose, then we say that they are not homogeneous. To become the homogeneous function, it should be k power n times of f of x comma y, and every term, all the terms should have the same degree. Then we say that it is the homogeneous function. Now let us solve. Now let us identify how the homogeneous equation will be there and then how to solve that actually. So now I am going to enter into the homogeneous differential equation. So what is meant by the homogeneous differential equation? We write some f of x comma y dx plus some other function g of x comma y dy is equal to 0. This is called homogeneous if is a homogeneous differential equation if f of x comma y and this g of x comma y are homogeneous functions of the same degree, or the homogeneous functions of the same degree. It cannot be of different degree. Okay, then we say that they are the homogeneous functions of the same degree. So let us solve the problems now. I'll just take now to do the problems. We will use some steps to solve this problem. That is one now. Steps to solve the homogeneous differential equation. So what are the steps here? Step 1 is always what we do is first identify whether it is homogeneous or not is the first step. Identify whether the given differential equation is homogeneous or not. Now the second point is once it is homogeneous, then always put y is equal to vx. This is what the substitution. Now when y is equal to vx, what is the derivative of y? dy by dx. Now v is also a function of x, so we use the product rule. V into derivative of x is 1 plus x into derivative of v is dv by dx. So the substitution here is dy by dx is v plus x dv by dx. Y is equal to vx. Now what we do is we plug these two values, substitute this y and dy by dx in the given equation, in the given differential equation, and then solve the differential equation, and after solving it, then substitute your equation will be in terms of v, right? So you have to substitute v value back. That means substitute v is equal to y by x in the solution. That is what the way you have to follow to solve the homogeneous differential equation. So let us now have see one problem to solve the homogeneous differential equation. So let us take one problem now. Find the general solution of the differential equation dy by dx is equal to x plus 3y over 2x. So first observe that whether they are of same degree or not. Yes. So when you take x degree is 1 here, y degree is 1, and the denominator also it is 1. So we can say that it is homogeneous. Once it is homogeneous, what we have to do? Substitute or put y is equal to vx. So what is the derivative? dy by dx is equal to v plus x dv by dx. So what we are now going to do is we call this equation as 1. So when you substitute these values here, dy by dx can be replaced by v plus x dv by dx, and then x plus 3 times of y. Y means vx over 2x. Clear? So now x you have to take common. 1 plus 3v over 2x. So now x gets cancelled. So what we get now? We get 1 plus 3v over 2. So now here it is, there is v here, right? So what we do? We subtract v. That means x dv by dx. If that v goes to the other side, it is 1 plus 3v over 2 minus v. So now how to solve this? You will be multiplying this with v and dividing by, with 2 sorry, and by 2. So that means this denominator, when you multiply and divide, then you will get the solution. So that is 1 plus 3v minus 2v, then the denominator is always the same. That gives you 1 plus v by 2. So this is what your dv by dx. Now let us do the cross multiplication. That is x dv by dx. We got it as 1 plus v by 2. So let us do the cross multiplication. So I'll write 2x dv is equal to, it is 1 plus v dx. So what we do, both the sides, this is x, it should not be here, and 1 plus v should not be here. So divide by x into 1 plus v. Then what we get? 2 dv over 1 plus v is equal to dx by x. I hope it is clear now. You are dividing by 1 plus v, you are dividing by x, because x is odd here and 1 plus v is odd here. So therefore 2 dv by 1 plus v. So when you do the integration, it implies, when you take 2 common, it is ln of 1 plus v is equal to dx by x is ln x. It's clear? So now you have to replace back what is v. So that is 2 into, I think it is constant, we have to be added, 1 plus v is equal to what? Y by x is equal to ln x plus the constant. So this is what the solution. This is what the solution. So I hope it is clear how to solve a homogeneous differential equation. So let us do one more problem. Let us have one more problem now. dy by dx is equal to y by x plus tan of y by x. Now it is clear that it's homogeneous because degree is 1 here, degree is 1 here, and here also 1, 1. So definitely you can say that it is homogeneous. The homogeneous differential equation. So what we do first, what is the substitution when it is homogeneous differential equation? The first substitution is y is equal to vx. Then what is its derivative? dy by dx. This is the constant substitution. So dy by dx is v plus x dv by dx. So let us substitute all these in the equation 1 now. So what is dy by dx? v plus x dv by dx is equal to y is vx over x plus tan v. So that is x gets cancelled. You will be remain with v plus tan v. So now if this v also goes to the other side, it is x dv by dx is equal to tan v minus v. Okay. So now tan v minus v plus v. So this way v gets cancelled. You will be remain with tan v. Okay. So now we have to take v to the other side, x to the other side. So it is x dv is equal to tan v dx. What we do now? Divide by x tan v. This is what we do. So what it gives you? dv over tan v is equal to dx over x. Let us solve this integral now. So what it implies? 1 over integral tan v is cot v dv is equal to dx by x is ln x plus the constant. So what do you know about integral cot? Integral cot x dx is what? Is given by minus ln of cosecant x plus c. This is what the formula, correct? Integral cot x is minus ln of cosecant x plus c. So we do now what it is. Integral cot v is minus ln of cosecant v is equal to ln x plus the constant. So this is what the solution. Minus ln of cosecant v. So you can even write that ln of cosecant v on the other side. So ln of cosecant v plus ln x plus c is equal to 0. So with this, we have finished the solution for the homogeneous differential equation of the one more problem also. So I hope it is clear. To first substitute y is equal to vx and then find out dy by dx, and then substitute y is equal to vx when you do, then what happens? So you can see that and then get the solution. I hope it is clear, all of you. So same way you can do some more problems of this type. Let us try this problem as a homework for you. So just to solve this, because dy by dx, the third problem you can do by yourself. Dy by dx is given by x square plus y square over xy. So again it's a homogeneous. Why? Because the degree is 2 here, the degree is 2 here, and this is 1 and 1 each. When you are multiplying, you can do like this, okay? So it is, the degree is the same, so it is a homogeneous differential equation. So I hope you can do this problem. With this I will finish this lecture.